Welcome. Transformation, rotation, and reflection. So here you have the question. On the Cartesian plane below, triangle PQR has vertices P, 2, 3, Q, 1, 2, and R, 4, 1. While triangle P double prime, Q double prime, R double prime has vertices P double prime, negative 2, 3, Q double prime, negative 1, 2, and R double prime, negative 4, 1. So there we have both the triangles PQR and P double prime, Q double prime, R double prime. Let's go to the questions. Part 1. Describe fully the transformation which maps triangle PQR onto triangle P double prime, Q double prime, R double prime. B. On the same plane, draw triangle P prime, Q prime, R prime, the image of triangle PQR and a reflection in the line y is equals to x. C. Describe fully a single transformation which maps triangle P prime, Q prime, R prime onto triangle P double prime, Q double prime, R double prime. And then we have D. Draw triangle P triple prime, Q triple prime, R triple prime such that it can be mapped onto triangle PQR by a positive quarter turn about 0, 0 on the origin. Then the last question, state a pair of triangles that is 1 oppositely congruent, then 2 directly congruent. So those are the questions. So very first we go to the first part of the question, where we are required to describe fully the transformation which maps PQR to P double prime, Q double prime, R double prime. So look at the diagram. So you need to describe the transformation which maps this triangle to this triangle that is here. So you need to understand all the transformations that we have. The transformations that we have are, just list them here. Think of translation. Think of reflection. Think of rotation. And understand the properties of each of these transformations. Think of shear. Think of stretch. Think of enlargement. I don't know whether I've left any other. I think these are the major ones. We have stretch, we have shear, we have rotation, we have reflection, translation, all these. Then, when you look at this transformation from this triangle to this, this one is a congruent transformation. A congruent transformation is a transformation that does not change the size of the object, the size and the shape. So when you look at both the object and the image, the shape and the size remains the same. So we have others here. That is why I've said you need to understand the properties of, let's say, a translation, a reflection, a rotation, shear, stretch. So you need to go through all these to understand. So very quickly, when you look at these two, there's something that you realize that will help you to identify the type of transformation. Number one, I look at this line, y-axis, and then look at this distance. For example, from Q to this line, which is y-axis, then from the y-axis to Q prime. That distance is the same. I look at P to this line, the y-axis, then from the y-axis to the image P prime. That distance is the same. So the distance from P to this y-axis, then from the y-axis to this P prime, P double prime. Look at R, that distance to y-axis, then from the y-axis to R double prime, the distance is. So the type of transformation whereby we have this distance, whereby this one will be the mirror line. This line will be the mirror line. So when you look at this, you notice that this one is a reflection in the sense that the mirror line is here. And that is why you can see the object points and the image points are directly opposite that line. Then the distance between the object point and the mirror line, and the mirror line and the image point is equidistant. the transformation that has that type of property is a reflection. So this one is therefore a reflection along the y-axis, or the line x is equals to 0. So that is how you identify that. So you write, describe fully the transformation. You just say this one is a reflection along the line x is equals to 0, and that line is what we refer to as the y-axis. So you have described fully. When you're describing a reflection, you have to state the line of reflection. Then the other part of the question, part B, on the same plane draw triangle P prime, Q prime, R prime, the image of triangle PQR and a reflection in the line y is equals to negative x. Now this kind of reflection, why we have this line y is equals to negative x, first of all you have to understand which line is that, and you need to reflect which image. These are object PQR should give a P prime, Q prime, R prime under that reflection. So you need to understand which is that line. That line is this line that passes through the center of these axes. Y is equals to negative x. You also need to understand y is equals to x. Which line is that? So the line is here. So this line that passes through the center, like that line is the one that we call the y. This is the line. This is the line. Y is equals to negative x. Now, there is something that I'll give you which will help you identify. This one is a line of reflection, so automatically this one will be directly opposite here, and the distance from Q to the middle line should be the same to the image point here. So the easiest way to identify this is something that you need to know, that under a reflection in the line y is equals to negative x, a point, let's say AB, a point AB under a reflection in the line y is equals to negative x is mapped onto negative B, negative A. Negative B, negative A. So what happens to the object points? They are reversed and they change the sign under these. This will help you understand. You don't need even to you just need to draw the line and then indicate the point. So under a reflection in the line y is equals to negative x, a general point AB is mapped onto negative B, negative A. The points are reversed and they change the signs. So therefore, when you look at the point that you have here, so we are reflecting PQR. So PQR, so P is look at P here. P is 2, 3. P is 2, 3. So this one will be mapped onto, and this reflection. So this P prime will be negative 3, negative 2. Then Q is 1, 2. This one will be mapped onto Q prime. This one will be negative 2, negative 1. Then R is 4, 1. 4, 1. So R prime will be negative 1, negative 4. So the points are reversed and they change the sign. So you need to plot these reverse. So P prime will be negative 3, negative 2. So negative 3 is here, negative 2. So P prime will be here. P prime will be there. Then Q prime, negative 2, negative 1, negative 2, negative 1 will be here. This is Q prime. And then R prime will be negative 1, negative 4, negative 1, negative 4. So that is R prime. So P prime, Q prime, R prime. So we can join these. So that is we plotted it. So you notice that, look at the object point like Q. where Q prime is P, P prime is here, R prime is here. So you can see the property of reflection, the distance between the object and the mirror line, and the distance between the mirror line and the image point, those are equidistant. So we have done that. So we are required to draw, and you've done that. So part C of the question, describe fully a single transformation which maps triangle P prime, Q prime, R prime onto triangle P double prime, Q double prime, R double prime, 2 marks. So we need to identify which type of transformation maps these to these. So this triangle to this. You notice that this type of transformation is a congruent type of transformation because the shape and the size does not change. Look at the individual points the way they are. P prime is here, P double prime is here, Q prime is here, Q double prime is here, R prime is here, R double. So you notice, apart from changing the position, the points have been rotated. You can see the points have been rotated. Q is here, Q prime is here, Q double prime is here. So the points have been rotated. So this one is actually a rotation within a certain center, or about as a given center of rotation. To describe fully a rotation, you need to give the center of rotation and the angle of rotation. So how do you get the center of rotation? I'll show you this one using construction. So join any object point and image point of your choice. Like in this case, I'll choose to join Q prime and Q double prime. Join that using our straight line, like this. So join that using a straight line, Q prime and Q double prime. Then construct a perpendicular bisector. Construct a perpendicular bisector of that line. So to construct a perpendicular bisector, just take your pair of compass and then mark an arc there, and then mark another arc here, like that. So I'll mark this arc, and then mark another arc there. So with the same radius, stand at this point, then cut that arc, and also cut the other arc here, cut that arc. So now when you join this point of intersection of the arcs, you've constructed a perpendicular bisector of that line, like that. You've constructed a perpendicular bisector of that line. The next thing, join any other object point and the image point. This time around, I will join P prime and P double prime. Join that using a straight line. So let me join that using a straight line, like that. Then again, construct perpendicular bisector of that line. So stand here, open it more than half of that line, then mark an arc there, bigger arc, then the same radius, mark another arc here. So with the same radius, I stand at P double prime is here, then stand at this P prime there, and then cut that arc that we've made, and then cut the other arc that is there. So we started by standing here. There's so many arcs I can see here, so that is the arc. You can see where they are intersecting. You can see this point of intersection here, the arcs. Then the other point is here. So you need to be very careful. There's so many arcs here, they can confuse you. The arcs are intersecting at this point. So that is how we do it. Where the two perpendicular bisectors are meeting, that is definitely the center. Where are they meeting? They are meeting the origin. The two perpendicular bisectors. Remember, we have constructed the perpendicular bisector of Q prime, Q double prime, and P prime double prime. The two perpendicular bisectors are meeting at the origin. So that is the center of rotation. that is the center of rotation. Now we want to identify the angle of rotation. Remember, what is being mapped to what? It is triangle P prime Q prime that is being mapped to P double prime. So join any point, the object point, like I'll join a Q. I'll join Q prime to the center of rotation. I'll join that center of rotation like that, Q prime, and then from the center of rotation to Q double prime. Q double prime is here. Q double prime is there. So this is what I've done. Now I want to get the angle of rotation. This is what is being mapped to this. So take the any object point. I've taken Q, join it to the center of rotation, then from the center of rotation to its image point. So Q prime, Q double prime. This angle that is here at the center, that is what is going to give the angle of, and you're measuring the angle from this line. So this is how you're going to place your protractor. Measure the angle. You're measuring the angle from the object, and you will notice that this will give exactly 90 degrees. To give you 90 degrees. So you're measuring the angle. Look at this from here. So going this way. So from here, you're measuring the angle in a clockwise direction. So from this line that you placed here, you're measuring it this way. So you can see this is exactly 90 degrees. So therefore, you can now go ahead and describe the rotation. So you've noticed that this one is a rotation. That one is a rotation about, give the center, about the origin 0, 0 through what angle? Through the angle. Since the angle is measured in a clockwise, the angle is measured clockwise from the object point. We measured the angle in a clockwise direction. That will be negative 90 degrees. If it is anti-clockwise, it is always positive 90. Now, after doing that, we can now go to, so you have described fully, giving the center and the angle. Now let's go to the other question. The other question is, draw triangle P triple prime, Q triple prime, R triple prime such that it can be mapped onto triangle PQR by a positive quarter turn about the origin. So you're drawing P triple prime, Q triple prime, R triple prime, which is going to be mapped onto PQR by, this one is positive quarter turn about the origin. How do you get now this? How do you get these P triple prime, Q triple prime, R triple prime? This is what you're going to do. If P triple prime, Q triple prime, R triple prime is being mapped to PQR by a positive quarter turn about the origin, what about the reverse? The reverse means PQR will be mapped to P triple prime, Q triple prime, R triple prime by the reverse of this. What is the reverse of positive quarter turn about the origin? It is a negative quarter turn. This is what is going to assist us, a negative quarter turn about the origin. That is the reverse. The reverse happens. So since we have a PQR, we are going to use this one to get this. So we shall now consider this triangle PQR and rotate it about negative quarter turn about the origin. Since this one is mapped onto PQR by a positive quarter turn, so the opposite will take PQR to that. So negative quarter turn. So we need to go to the diagram here and look at this PQR and rotate this one about, that is a negative quarter turn about the origin. Negative quarter turn about the origin. And this is how we do it. Negative quarter turn about the origin. So we join each point to the center of rotation. So we start with Q, join Q to the center of rotation. This is how we rotate it through negative quarter turn. Then from there, this is how you're supposed to measure the angle. Negative quarter turn, that is a clockwise rotation. We shall measure the angle in a clockwise manner. So we place the protractor like this. This is how we place it. So 90 degrees, measure 90 degrees. Like that. So you've measured 90 degrees from this line in a clockwise direction, like this clockwise direction. So this one is 90 degrees. Then from there, take this distance that is here. Take this distance, the distance from Q to the center of rotation. Take that distance and then stand here and mark this point here. So this is the position. This will be now Q. This will now be Q triple prime, Q triple prime, like that. It will be here. Do the same for other points. P, we do the same for P. So join P to the center of rotation. It is here. Join P to the center of rotation. Then after joining, measure 90 degrees. Measure 90 degrees so that you don't make mistakes here. So like that. So again, after measuring 90 degrees, so measure 90 degrees from this line going this way, clockwise direction. So take this distance from P to the center. Take this distance from P to the center. Then from this center, you mark that point here. You mark this point. Let me measure again here. So that is the distance. Then standing here, it will be exactly here. This will be the point. So you've taken that distance from P to the center, then same distance to this line here. So this will be P triple prime to be here. Then the last one is R. So join R to the center. Join R to the center of rotation, like this. R to the center. Then measure 90 degrees. Measure 90 degrees. This is how you measure 90 degrees. Be there. So you draw a line. Like that. We confirm that this one is 90. As indeed it is 90. It is 90 degrees. Then again, you take a pair of compass from this point to take this distance. Take that distance. Then from this center here, you mark. In the center here, you mark that distance here. So you mark that point. So this will be the point. So R triple prime will be here. Now you have all the points. Remember we got P. P is we got P. P the triple prime is here. Q is here. Q triple prime is here. And then R triple prime is here. So join the point. join the points now. Join all the points. So I have drawn it, but it's clear. So P triple prime is here, Q triple prime is here, and R triple prime is here. I've done it. So I need to at least shade these ones so that you can see them. You can shade them for purposes of clarity. Can be clear. I've shaded it there. So the other one is here. Can shade this one as well so that it can be seen. The other one is here. And then the first one, the original one, is yeah. So the four of them are there. So I've done that. I've drawn P triple prime, Q triple prime. I've done that triangle. We're done with that. Now the last question is state the pair of triangles that is oppositely congruent, then directly congruent. Now you need to understand what is the meaning of oppositely congruent. These are triangles. For them to fit, exactly fit on each other, of course they must be of the same shape and size. You have to actually turn them over for them to fit exactly onto one another. It's not just a matter of sliding. You have to turn one triangle over so that it fits onto the other one. Then directly congruent, these one are just two triangles where you just need to slide. Just to slide, you don't need to turn over in order for them to fit. So we need to identify the ones that are oppositely congruent. When you look at these, the first one, when I look at these, I'll notice that PQR and P triple prime, Q triple prime. So this one and this one. So for this one to fit onto this one, you notice you cannot just slide this one onto this. It will not fit. If you slide, you have to turn it over. You have to turn over this one so that it can fit onto this, or you have to turn over this one so it can fit onto this. So this one is oppositely congruent. So the first one is P. Just give one pair. So PQR and P double prime, Q double prime, and R double prime. So those two. So these ones. So the pair that is oppositely congruent, PQR and P double prime, Q double prime, R double prime. So those ones, you have to turn over this one completely, not just sliding. You have to turn it completely so it can fit onto this. The same case to this. Then we can now give the one that are directly congruent, this one and this one. Look at where the points are. When you look at Q and look at this Q that is here. Okay, look at this Q. Q is here, Q is here, then P is here, P is here, this one. So this one you just need to slide this one over this, and it will fit. It will just fit. So this one is another example, this one and this one. So for this and this, you don't need to turn it over. You don't need to turn it over. You just need to slide to this one and then twist it a little bit. So we can give the ones that are directly congruent. We have PQR, and we also have this is P triple prime, Q triple prime, and R triple prime. So these are the ones that are directly congruent. Then PQR and P double prime, Q double prime, R double prime oppositely congruent. Just understand what we've said about oppositely congruent. You have to turn over for one to fit onto the other, and you've given this and this, so you have to turn over this one to this for it to fit. But when you look at this one, oppositely directly congruent, this on this, you just need to slide this one over this and then just twist it a little bit. You don't need to turn it over. So that is how you are supposed to answer the whole of that question. Thank you.